For this slide, we're going to talk about translations and specifically translating on a coordinate plane. The first thing that I wanted to point out is the notation we're going to use right here. Just notice that we're going to be using the uppercase T to stand for translation. And I want you to take a look at the subscript right here. The subscript that we're going to use is the vector of translation. A translation, in other words, is a shift or a movement. Alright, so we're literally going to be taking, you can see the figure here, taking a figure and shifting it or moving it in a certain way. The vector is the direction and length we're going to move it. So a vector has direction and it has length or magnitude. So how far are you going to move it and in what direction? And again, in the parentheses, we have what we're going to be translating. Alright, so we're going to take a look at some of this stuff and how it looks on a coordinate plane. Okay, so for this one here, very straightforward, just to show you how an object can be translated on a graph. For this first one here, it's telling us specifically it wants us to go 2 units down and 3 units to the left. If we're going to do that to RSTU, this square, we're going to have to do it to each point. So we'll start with R. We're going to have to go down 2 and to the left 3 units. That's going to end up with our R prime right about there. We're going to do that for every point on this square. Down 2 to the left 3, there's U prime. Down 2 to the left 3, there's T prime. And the same thing with S, there's S prime. We can connect to get our new triangle, new square that has been translated. The second thing this question wants us to do is draw the vector that defines the translation. To draw the vector to define a translation, all you have to do is simply connect 2 corresponding points. So we'll take R and R prime. If I connect R to R prime and put an arrow there, that is going to be the vector that defines how this square moved. Alright, there's a vertical component, the down part. There's a horizontal component, the left part, but the one vector that defines it is any vector that connects corresponding points. If you'll notice, if you connect T to T prime, it's the same arrow, same length, same direction. Number 2 is the same thing. I'm not going to go through it, but you can take a look at it if you'd like. Alright, we're going to take a look at a really quick, simple example of a translation on a coordinate axis with coordinate points. Now you can see we have 2 coordinate points, coordinate A, coordinate B, and we are going to translate line AB by translating each point. Now I'll give you a rule here, or a translation rule. The first one right here is one way you may see a translation rule written. Again, you see the T for translation, and the numbers here actually represent how to move in the X direction and how to move in the Y direction. The X, of course, being horizontal, the Y being vertical. So for this translation rule, they're asking us to move 3 units in the X direction. That's 3 units that way. And -1 unit in the Y direction, which is down 1. So our new A prime would end up right there. We use the same movement for the B prime, 3 over down 1. So there's B prime, there's A prime, and there's my new line. Okay. Another way you may see that written is using a rule like this, where it's literally the same translation, it's just written differently. Here they're just being more specific about what to do in the X direction, add 3 in the horizontal direction, and subtract 1 in the vertical direction. Alright, but the result of the translation would be the same. Again, if you wanted to show the translation vector, you would just connect corresponding points, and there's your translation vector. In these examples, we just want to get off the axes or get off a graph here and just apply these translation rules to coordinate points without the use of a graph. So again, you're going to see in this first example a translation rule written out where they want you to add 2 to the X and subtract 3 with the y. If you were doing this on a graph, you'd move to the right 2, you'd move down 3. We're not on a graph, we're just going to apply that translation rule to this point. So we're going to simply add 2 to the x. So 5 becomes 7, subtract 3 in the y, that becomes a 0. So 5, 3, translated using this rule, becomes 7, 0. I can apply the same rule to 3, negative 4, and get a 5 in the x and a negative 7 in the y. Okay, again, applying that rule. For number 2 here, real quick, it's giving me a translation rule of negative 4, 0. Again, that's the x, y. So they're asking me to subtract 4 in the x. I can do that. 7 minus 4 gives me the 3. They're telling me that add or subtract 0 to the y, so the y essentially remains unchanged. So my resulting point is a 3, 3. For this third one here, what I would like to see you try to do is, in your own words, please describe the translation rule of how we got from point A to A prime in your own words.